Hello students, this video intends to help aid in your understanding of dependence, independence, the multiplication rule, and conditional probability as they are presented in the Stat 1040 and 1045 classes. Within this video, we will touch on objectives 4.1, 4.2, and 4.3 of Unit 4. We will be covering the concepts shown on screen. After some explanation, you will have a chance to practice these concepts at the end of the video. Let's get started. We will begin by learning about how independence and dependence function in probability. In probability, events are independent if whatever happens in outcome 1 has no influence on whatever happens in outcome 2. For example, if we were rolling 2 fair dice, the outcome of one die would have no impact on whatever outcome we get from the other die. The rolling of one die is a completely separate event from the rolling of another die. If a problem mentions that there is replacement, such as if we are drawing from a set quantity of something, the problem is independent since our probabilities will not change as we replace what we are taking out. On the other hand, events are dependent if the outcome of one event does affect the chances of the outcome of another event. Dependence is commonly seen when there is no replacement within a problem. Next, let's learn about the multiplication rule, also incorporating our knowledge of independence and dependence. We use the multiplication rule when we wish to find the chance that different outcomes are occurring at the same time. We can represent the multiplication rule by saying the probability of A and B is equal to the probability of A multiplied by the probability of B. When reading a word problem, you will want to look out for words such as and, both, neither, all, or none. These indicate that you will be doing the multiplication rule in order to solve for the answer. When doing the multiplication rule, we must check if events are dependent or independent from one another. Depending on if there is dependence, the way we set up our problem changes a bit. When outcomes are independent of each other, their numerator and denominators do not change when they are multiplied together. For example, if we are determining the chance of rolling a 6 on one die and a 3 on another, we would represent this as 1/6 times 1/6. Between one event and the other, we are not changing any numbers, since these dice are independent from each other. When outcomes are dependent, our numerator and denominators can potentially change when we are multiplying our outcomes. For example, please note the problem below. Noting that we are taking these eggs out and not replacing them, and further noting the word both that indicates the multiplication rule, we would represent these probabilities as 3 out of 12 times 2 out of 11. So, why did the numbers change between event 1 and event 2? We are picking from the total number of eggs, therefore taking 1 away from our denominator. Our numerator likewise changes in this case to reflect the fact that we are taking from the total number of broken eggs. Let's further deepen our understanding of probability by reviewing conditional probability. The word given indicates the presence of conditional probability, as seen in problems where it asks us to find the chance of an event occurring given that another event has occurred. Please note, when you are not given any indication on what the outcome was of a previous draw, you must proceed as if the draw did not happen. For instance, look at the problem below. Since we are not giving any information about the outcomes of previous draws, we will simply have our answer be 1/6. Now that we have reviewed some of the concepts of probability, let's do some practice to check our understanding. A rec center employee is sorting through their stock of volleyballs. Of the 15 they have, 3 are overinflated, 5 are underinflated, and the rest are just right. Question 1. If an employee takes out 3 balls at random, what is the chance that all 3 she picks are underinflated? Pause to answer, then press play to check your understanding. Answer. Here are some ways you could have represented your answer. We were able to find this chance by recognizing the word all, which indicates the multiplication rule. Next, we check the problem for independence. Since the employee is taking the balls out, this problem does not have replacement, and therefore our draws are dependent. Since we are depleting from our total number of balls each time as well as the total number of underinflated balls specifically, both our numerator and denominators must change when we multiply these events together. Question 2. Given that the previous 2 volleyballs selected were perfectly inflated, what is the chance that the employee will select an overinflated ball on her 3rd draw? Pause to answer, then press play to check your understanding. Answer. Here are some ways you could have represented your answer. We are able to find this chance by picking up on the word given, which indicates that we are working with conditional probability. Furthermore, since we are explicitly told the outcome of the 2 previous draws, our 3rd draw will be affected. Since the balls taken out were perfectly inflated, we are subtracting 2 from our total. However, our number of potential overinflated balls remains the same here, since we have not taken out any overinflated balls in our previous draws. Question 3. If the employee replaces the ball she takes out each time, what is the chance that all 3 of the balls she picks are overinflated? Pause to answer, then press play to check your understanding. Answer. Here are some ways you could have represented your answer. We found this chance by noting the keyword all, which clues us in that we are doing the multiplication rule. We also must recognize that since the employee is replacing the volleyballs, this problem features independent events. When we are setting up our events to multiply together, we do not change either the numerators or denominators, since these events are independent. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video was helpful, and remember that help is here if you need it.